This video is about using a micrometer. It accompanies Lab 4, the hysteresis oscillator and touch sensor, and corresponds to section or part of section 17.4 of the Applied Analog Electronics textbook. Now, the problem we're addressing is that when we are making the touch sensor, we have to make a pad that we touch. And this consists of a conductor covered with an insulator, so that when we touch it, we're forming a capacitor, with the one plate of the capacitor being the metal and the other being our finger, and the insulator between being the coating on the metal. And the way we do it for this lab is we make the metal just out of aluminum foil, a few layers thick, so that it's stiff enough. And then we make the insulator by taking a piece of packing tape, putting it on one side, folding it over, putting it on the other side. So we've got both sides here covered with packing tape. And then when we touch it, the area of the two capacitive plates is basically how much of this plastic packing tape is the finger touching. The thickness of the insulator is the thickness of the packing tape. And so we need to know, when we're calculating what is the capacitance of that touch, how thick is the tape? The problem is that when we buy packing tape, at least when I buy packing tape, I get some very cheap tape, and I have no idea what the thickness of the tape is. It comes in many different thicknesses. The more expensive stuff tends to be thicker than the cheap stuff. But I don't know what I've got. So, the solution is to measure it. And the tool that we use for measuring is a micrometer. A micrometer is for measuring the thickness of small objects. This particular micrometer has a resolution of 0.01 millimeters. That is to say, 10 microns. So fairly small measurements. And it'll go from 0 to 25 millimeters with that resolution. All right. So, how do we measure tape? Well, we don't want to get sticky stuff on the micrometer. So, we're not going to measure the thickness of a piece of tape. What we're going to do is measure the thickness of two pieces of tape folded over. So, you've got the tape covering the aluminum foil, then folded over, covering the other side, and the two pieces of tape are stuck to each other. Now there's no sticky side here. So we can measure this without making our micrometer all sticky. The way you use the micrometer is to first remove the brake by pressing this off to the side. This has the brake applied, this has the brake released. So you can open up the micrometer by turning this big knob in this direction so that the plates here move apart. And if you look at the barrel here, you can see that it's got numbers on it and little tick marks. When we've got this thing closed all the way, and to close it down, use just the little knob, because when you get to the end here, you get a clicking sound and the large barrel no longer turns. So this little slip clutch arranges so that it's always providing a constant force when it is closed or when it's closed on an object. And that keeps you from crushing the object and allows you to have a repeatable measurement, so you have always the same amount of force applied. All right, so if you notice, there's a little line here right next to where the brake is, and that line is lined up with the 0. So when this thing is closed all the way, I have a reading of 0. If I open it up and do a full turn, it's gotten up to 50, so from 45 to 50, and that's 50 of these 10 micron units. So that's opened up the gap here, half a millimeter. If I turn it again, a full turn, now I've opened it up, not 50, but 100 hundredths of a millimeter. So it's now a 1 millimeter gap here. And I can keep doing that up to 25 millimeters, which is the range that this micrometer has. It's hard to count the number of full turns you've done, so let's just open it up a few times. You can see that there's some vertical lines on the barrel here. Each time we expose one of the bottom ones, that's an odd number of turns. Each time we expose one of the top ones, that's an even number of turns. So the gap here, I can see 1, 2, 3, 4 turns there. I can see on the bottom that I've got 5, and I've completely exposed this one. I'm about to expose another one on top. So that tells me that this thing at the moment has got 5 millimeters of gap. Okay, so that you can count by counting half 1, another half 2, and so on. You can count larger distances without having to count the number of turns you made on this. But what I'm measuring right now is much smaller than that. So I'm going to close it down a little bit, and now I'm going to stick the tape in to the gap. And this is always a little bit tricky because I don't want to pinch my finger, and I also don't want to drop things. All right, and I always close it down with a little knob here so that when I get to the end, it clicks. And I can read opposite that little line there. It looks like it's lined up at 9, one just before 10. Okay, so that says there's 90 microns is the distance between the plates of the micrometer. That doesn't mean the tape is 90 micrometers though, because remember this was 2 thicknesses. So each thickness individually is only 45 microns. And basically that's all you have to do is to measure with the tape you've got what a double thickness of it is, and try to avoid doing it where there's folds or bubbles in the tape, because the thickness will be different there than other places, and you want to measure just double thickness of tape, not anything else. And this tape here also seems to be 90 microns for the double thickness, so it's also 45 micron tape. Okay, that's all there is really to using the micrometer.